Good morning, children. Today we are going to discuss about the topic is light, reflection, and refraction. This is the first topic in your 10th class and important topic, and questions will come. And it is easy topic. And you have a few knowledge about light and in your lower classes. See, generally we are talking about light means where we require light. In regular days, we will use every time we need a light. Suppose if you went to a room and the room is dark, what happens? You cannot see anything. You can't see anything. Whenever you can't see anything, what you will do? You will light up the room. That means you'll switch on the light. That means here light becomes things visible. What is meant by light? In a living room and in lighting of the room, the things become visible if you switch on the light. That means light gives sensation of vision to our eye. That means during the day, the sunlight helps us to see the objects. In the night times, we'll use a lamp or else bulb or anything. Which one we'll use the things. And in lower classes, I think some idea about the light. That means in lower classes, had you learned about some phenomena of in sixth class onwards objects, what is opaque objects, what is meant by transparent objects, and all those things will come in lower classes. Now we will go for little bit advanced here. In this class or in this chapter, what we learn in lower classes, beyond it we will go, and you have learned some basics in lower classes as what is the phenomena of reflection. Reflection means when light falls on the boundary of the two media, a part of light gets back into the same medium. That phenomenon is known as reflection. What is meant by reflection? If you don't know, please note down the definition of reflection. When a light falls on boundary of the two media, the light gets back into the same medium. Such phenomenon is known as reflection. Such phenomenon is known as reflection. Later on, we'll talk about refraction. Whatever the light will go to the other medium, that means it will go to the other medium, and that light is called as refracted light. That means basically here we will discuss about two things in this chapter. One is reflection of light, other one is refraction of light, and we will assume here the light is traveling in straight line path. The light is traveling in straight line path. And some optical phenomenon in nature. And in the next chapter, we'll discuss about what is the human eye and what happens, how the human eye is working in light, and we'll discuss that. And here we will discuss something else beyond it as reflection. Some beautiful phenomena also there, twinkling of stars and blue color of the sky, and all these phenomena also will be discussed in the next chapter. Now, in this present chapter, only we will discuss the phenomena of reflection and refraction. And reflection in case of plane mirrors, reflection in case of spherical mirrors. Like that, we will discuss here. This is all about the introduction of light. Now, in this chapter, first we will discuss the phenomena of light. What is the definition of light? Reflection of light. Already just now I defined to you. When light falls on the transparent medium, a part of light gets back into the same medium. That one is called reflection of light. This phenomenon is called reflection of light. Now, here we are a discussion doing about the reflection takes place at plane mirrors, and also can reflection takes place at spherical mirrors. Reflection can take place from plane mirrors as well as reflection can take place from spherical mirrors. Then plane mirrors already in lower classes are already defined. That means what are the laws? That means very simple. That means if you are considering that this is the incident ray, see here, I already drawn the diagram. This was an incident ray which is falling on the boundary of the two media. This red one is boundary separating two media. Then a part of light gets back into the same medium. This one is part of light gets back into this one. This is called reflected light. And this green one is normal. Normal means perpendicular to the boundary. Perpendicular to the boundary. Now, as we know that the angle between incident ray and normal is called angle of incidence. What is the angle of incidence here? Can you note down? if you don't have. Angle of incidence is the angle between incident ray and normal. Then what is the angle of reflection? Angle of reflection is the angle between reflected ray and normal. These two definitions, please note down. What is meant by angle of incidence? It is the angle between incident ray and normal. What is angle of reflection? It is the angle between reflected ray and normal is called angle of reflection. Now, what are the laws of reflection of light? What you learn in lower classes already. What we have learned in lower classes is the laws of reflection of light as there are two laws. You can see here the incident ray, reflected ray, and normal should lie in the same plane. See, in this diagram, I have shown a yellow line. That yellow line signifies that it is a plane. That means this incident ray and normal and reflected ray are lie in this plane. This is the plane. In this plane, the incident ray, normal and reflected ray are lying. This is called first law. And second one is the angle of incidence is equal to angle of reflection. These two are called laws of reflection of light. Note down these two laws also. Incident ray, reflected ray, and normal should lie in the same plane. Second one is angle of incidence equal to angle of reflection. This is the diagram. All of you note down without any mistake and maintain the notes. Now, we'll discuss what are the different types of reflection. There are two types of reflection. One is called regular reflection. Second one is diffuse reflection. What happens? What is the difference between regular and diffuse reflection? Suppose regular reflection is also called as reflection from smooth surface. Let's consider this is smooth surface. And as we consider a parallel beam of light falling on it, it's a parallel beam of light which is incident on the surface. Then the reflected beam also parallel to each other. That means this one is incident beam of light and this one is a reflected beam of light. So why it happened? Very simple. Here all the normals are parallel. For a regular surface, all the normals are parallel. That's why if incident beam is parallel to each other, then reflected beam is also parallel. The reflected light rays are also parallel to each other. Such reflection is known as regular reflection or also known as reflection from smooth surface. Can you note down the definition? What is regular reflection? When a parallel beam of light, is incident on a surface, then a reflected light is also, reflected beam of light, reflected light rays are also parallel to each other. Now, when we come across to diffuse reflection, it is also called as reflection from a rough surface. Let's consider this is a rough surface. And parallel beam of light is incident over it, just like previous case. These are parallel rays which are incident on it. Now, what about normals? The normals are not same. As normals are not same, as angle of incidence equal to angle of reflection, the reflected rays are not same. This is. That means incident beam is parallel to each other. This is incident beam. And it is reflected beam. Here, incident beam is parallel to each other, but reflected beam is not parallel to each other. Such reflection is known as which one? Diffuse reflection. Can you note down the definition? What is diffuse reflection? Is also called as a reflection from a rough surface. Here, why it is not parallel to each other after reflected light ray? Since normals are having different directions, they are not parallel. That means diffuse reflection definition is if a parallel beam of light is incident on a surface, then reflected beam is not parallel to each other. Such reflection is known as diffuse reflection. Now, what are the important points regarding the about reflection? This is all revision. Whatever you learn in lower classes or 6th, 7th, 8th, these points only already discussed. Just now I'm revising and I'm going for the new topic. Important points regarding about reflection. Now, this reflection is applicable for the laws of reflection are valid for all reflecting surfaces, either the surface is plane or curved. What is the point I'm saying? Laws of reflection are valid for all reflecting surfaces, either plane or curved. We'll explain. See, let's consider a plane surface, and it was the normal. Now, as light is incident, this is angle of incidence, and this was angle of reflection. Angle of incidence equal to angle of reflection, and all lie in the same plane. Now, if I take a curved surface, this is a curved surface, normal, and it was the incident ray, and it was the reflected ray. And angle is I, and angle is I. If I take another curved type, and here it was normal, L1. Then, as this was incident ray, making some angle, the reflected ray also makes same angle. That's why laws of reflection is valid for all reflecting surfaces, either plane or curved. This is the first important point. The second important point is, if the light ray incident normally on a reflecting surface, if the light ray incident normally on a reflecting surface, after reflection, the light ray retraces its path. Immediately everyone will get one doubt. What is the meaning of retracing? Retracing means it follows the path which was followed before incident on the surface. The same path it follows. See, suppose it was a reflecting surface and a light ray striking the surface normally. That means this is incident ray. Therefore, what is angle of incidence here? 0. Angle of incidence is how much? 0. Then the reflected light ray also follows the same path. That means angle of reflection is 0. Why? Means as angle of incidence equal to angle of reflection, by laws of reflection, if the light ray incident the surface normally, that means the angle between incident ray and mirror is 90 degrees. That's why, so that angle of incidence is 0. Therefore, angle of reflection also must be 0 by laws of reflection. Then it retraces its path. Whenever a light ray strikes the mirror normally, it retraces its path. It follows the same path as incident. Therefore, here what is the angle between incident ray and reflected ray? Here, angle between incident ray and reflected ray is 180 degrees. Here, angle between incident ray and reflected ray is how much? 180 degrees. Next, third one. Third point. Now here reflection is taking place. Whenever reflection takes place, what happens to the properties? That means what are the properties we know? Frequency, wavelength, speed. Frequency, wavelength, and speed. Last year also in waves we have discussed. That means last chapter sound topic we have discussed these properties. Frequency, wavelength, speed of the wave or reflected wave does not change. That means whatever the frequency is there for incident light and reflected also light also having same frequency. Incident light have certain wavelength, means same wavelength for reflected light also. Incident wave has some certain speed, means the reflected wave also will have same speed. That means during reflection of light, note down this point, during reflection of light, frequency, wavelength, and speed does not change. This will not change. During reflection of light, frequency, wavelength, and speed does not change. Does not change. These are some properties, and along with it, Now, if light is falls on a surface, light falls on a surface, and what is the deviation of light ray? Here just now I told to you the angle between incident ray and reflected ray is 180 degrees. That means incident ray was deviated by 180 degrees after falling on the surface. Initially it's going straight and it was turned back. That's why the light ray was deviated by how much degree? 180 degrees. Suppose if I incident with some angle, what is the deviation of light ray? That means we can draw a diagram here. Suppose it's the boundary separating and the yellow line is the normal, and a light ray was incident at an angle I. If I extended the dotted line, that is the actual path of the light ray. But due to reflection, the light ray follows the yellow path, sorry, blue line. The light ray follows blue line. That means it is reflected. That means instead of going in straight, it was deviated. It was deviated by how much angle? Very simple. This is the deviation we can denote with delta, small delta. That means, as you know that angle of incidence equal to angle of reflection, this was also I. That means this total angle is 180 degrees. How, where to where? I will show you here. This total angle is how much? 180 degrees. Now it was deviated. Therefore, here 2I plus delta is equal to 180 degrees. Deviation is 180 minus 2I. What is the deviation of light ray when it falls on a surface? 180 minus 2I. It is also coming in your 8th class or 7th class, lower classes, you get this point. What is the deviation of light ray? 180 minus 2I. That's why if angle of incidence is 0, then deviation is 180 degrees in the previous case. Okay. Now, next point. By keeping the incident ray fixed, if you are rotating the mirror through an angle theta in clockwise sense, then reflected ray also rotated through an angle 2 theta in the same sense. That means clockwise mirror was rotated. The reflected ray also will be rotated by angle 2 theta. See here how it will happen. Let's assume that a light is falling on it normally. Then I'm showing the reflected ray with green color. The reflected ray with green color. Then rotate the mirror. That means if I'm rotating the mirror, in which sense? Clockwise sense. This dotted one is the initial position. This was rotated by an angle theta. But incident ray was still fixed. That means incident ray was still in this direction. Now, what happens to the normal? Initially, the normal is in the same direction. Now, as the mirror was rotated, the normal was also rotated. Therefore, this angle was theta, means this will be 90 minus theta and this will be theta. This will be theta. Therefore, now after rotating the mirror through an angle theta in clockwise sense, therefore, the normal was also rotated by through an angle theta in clockwise sense. Due to that reason, now angle between incident ray and reflected ray is how much? Theta. Angle between incident ray and normal is theta. Now the reflected ray, you know that this was the reflected ray which makes same angle theta, which was same angle theta. That means initially I have shown the reflected ray with green, then here also I will show with green color. That means the reflected ray is making an angle theta with normal. So that how much total angle it was rotated? It's very simple. It was totally rotated by how much angle? 2 theta. Initially, the green line was rotated by an angle 2 theta. That means by keeping the incident ray fixed, if the mirror was rotated through an angle theta, then reflected ray rotates through an angle 2 theta. Note down these points. By keeping the incident ray fixed, the mirror is rotated by an angle theta about an axis in the plane of mirror, The reflected ray is rotated through an angle 2 theta in the same sense. The same sense. These are some important points regarding about reflection of light.